Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is Module 036, Telecommunications, Network Design and Management. Please follow me in my lecture series by subscribing to my YouTube channel at https://youtube.com/@NdinechiMichaelC. Like, share, and drop your comments in the comment section or reach out to me using my email addresses. You can also listen to my lectures on basic concepts of electronic communications, part 1 and 2, using the link given. I would also like you to visit Ebony Educational Consult website. For more lectures, you can do that by visiting www.ebonyeducationalconsult.com. You will see a series of lectures in that website that may be very useful to you. Now, back to our lectures today. Introduction. The world is currently witnessing a tremendous expansion in the area of telecommunications network and its deployment. This expansion can be seen from things like the migration from IP version 4, Internet Protocol version 4, to IP version 6. We can also see that movement from long-term evolution, which is otherwise known as 4G communication network, to 5G, and also moving up to 6G. So all this movement is as a result of expansion, and each expansion requires further planning, network design, and redesign. So in our lectures today, we'll be seeing this network design and how you manage those design when you want to add additional facilities or you want to expand the network to contain more users. So as companies realize the cost benefits of productivity gains created by moving or creating new network technologies, they began adding networks and expanding existing ones almost as rapidly as new technologies and products were introduced. By the mid-1980s, growing difficulties from these expansions were being felt, especially by those companies that had deployed many different and incompatible network technologies. The primary problems associated with network expansion are the day-to-day network designs, operation management, and strategic network planning. Specifically, each new network technology requires its own design, operation, and maintenance. When in our future lectures, we will see how all these operations and maintenance centers help to manage the whole network. But for now, let's continue with our design and planning. So some years back, strategic planning for this network expansion became a nightmare for telecommunications vendors. The staffing requirements, for instance, alone, for managing large heterogeneous networks created a crisis for many telecommunication vendors. Therefore, automated telecommunication network design and management, including network capacity planning and integrated across diverse environments, became an urgent need. And that is why, as a telecommunications engineering student, you have to be abreast with all what it takes to manage such a heterogeneous network. So, telecommunications network design, connecting the vast number of telecommunications facilities requires careful design and organization of transmission networks. Systems now involve many user and remote facilities. Large networks interconnect several large computers with networking and other essential requirements. Telecommunications networks are designed, built, and maintained to cope with the task of moving information within and outside one carrier. As a result of that, there must be standards. So the process begins with a statement of need that network must address. That is the design. For you to roll out any telecommunication network, you must start by stating the needs that your network must address. If you fail to define the needs very well, you see your network will not deliver what is expected of it. So initially, these are expressed as general requirements. You specify the general requirements. How many users do you want to serve or approximate users? What expansion are you looking at? It will be different from what is actually on the ground where you go into the field to deploy. Then, as the design develops, the statement of needs we saw above becomes more specific and more technically evolved. That is when you now start looking at what equipment can serve your purpose, what vendor can provide the equipment you need, but at the initial design, what you just needed is to specify the basics, the area of coverage, the possible number of people you will serve, where you will put your substations, and all those things. Then as you develop these things, more things come into being. You become more specific and become more technically evolve. Telecommunication network design goals. The network design process must obtain a configuration that provides a cost-effective arrangement of the links and the nodes. When we talk of links here, we are talking of the channel connecting different nodes. The nodes here are the stations or substations or the components that are required to communicate within your telecommunication network. This configuration must meet the basic standard of one, traffic volume. The network must handle a specific level of data traffic without becoming congested. Remember, when your network becomes congested, calls will not go through, messages will not go through, and your customers will become frustrated. Two, connectivity. All users must communicate only with the proper resources and avoid illegal resources. By illegal resources here, we are looking at those nodes that will be trying to hack into the system and listen to conversations or tap messages. So your connectivity must be able to identify only legal resources that are supposed to be part of the network. Fault tolerance. The network must meet a specific level of reliability as defined in the design criteria. In most communication systems, you are required to meet a reliability of 99.99%, which we call the 4 nines, 99.99%. If you design a telecommunications network that fall below 99.99% reliability, it is assumed that some useful information may be lost on any given day. Versatility. The network must accommodate various communication protocols and data transmission equipment. By this, we are saying that many vendors manufacture different data terminal equipment. If you take, for instance, your telephone handset, you have different vendors that manufacture telephone handsets. So your network must be able to accommodate most of these, handsets, which we call the data transmission equipment here. So without that, you see your network will be very, very limited. Then you also talk of your telecommunications network life cycle. The telecommunications network life cycle refers to the complete set of stages that the system goes through from its initial concept to its replacement. This life cycle involves one, planning and requirement analysis, design, deployment, operation and maintenance, and decommissioning. I want you to look at these 5 items and in the comment section, tell me what and what are involved in each one. For instance, let's look at the commissioning. See, when you roll out your telecommunication system, there may get to a point you are required to change from analog system or using analog devices to digital devices. At that point, that analog system has come to its end of life. So you have to decommission it and replace with digital equipment. So that is, an example of decommissioning. So for operations and maintenance, deployment, planning, I want you to look at each of the stages and be able to tell us what that is contained in each of them. Your answer is expected in the comments section. Now, in defining a network life cycle, it will make more sense if the description is carried out focusing on an aspect of the telecommunication network system. For instance, the deployment life cycle may not be the same thing as the decommissioning life cycle. So you take an aspect of it and give it a life cycle. If you are, rolling out a telecommunication network, you must, give a time lag within which you will deploy and let everybody access your network. Now, the network grows as the new data equipment and or circuits are introduced. As your network is operating, the manufacturers, the vendors of data terminal equipment must be also evolving from one stage to the other in the design and manufacture of their equipment. So your network must be able to look ahead so that if changes occur, you'll be able to expand or reconfigure your system to adapt to new technologies in the data communication equipment. It grows to a point where existing data communication equipment and or circuits are no longer adequate and are replaced with more modern and probably higher capacity ones. So at that point, what you have done, you have to decommission to be able to migrate to new devices that, are out by that time. Now, these networks or these telecommunication networks come in different forms, and there are 5 basic categories of them. These network configurations are also known as the network topologies, and irrespective of whether you are using wired or wireless, you must employ one, two, or combination of different topologies to be able to deliver your telecommunication services. So no matter the combination, you have also a combination of many of them or all of them. When you have that, you call that a hybrid network. But let us quickly look at the topologies one by one. Then on your own, you can see how 2, 3, or 4, or all of them can be put together to work as a single network. So the first one we look at is the star network. The star network is used where there is a central switch. That is, have a central switch controlling all the other networks or all the other switches or nodes, as the case may be. It is common, this star network is common for local area networks and are usually not recommended where wide area networks are to be employed. They are not usually resilient because they have only one route to each node. You say it has a central node or central switch which connects to all the nodes separately. So if peradventure there is a breakdown in that central switch or central hub, then all the systems experience blackout. This setback is taken care of by the use of redundant hot standby as a backup system in case of failure of central switch. So in telecommunication systems, when you have such, a layout that a center is controlling all the other connections, it is always good to have a standby or a backup or a parallel working, switch, so that if one fails, the other one takes over automatically. This taking over automatically is what is known as redundant hot standby in telecommunication system. So star network are best suited where the communicating facilities are separated by large distances, more especially if you are doing cross-continent transmissions. Message delay is likely because of the throughput limitations at the central hub, leading to queuing. Now you're having a central hub. Every message from one node to the other must pass through the central hub or central switch. So there will be a time more than the capacity of the hub will be the message more than the capacity of the central switch will arrive. When they do, then some must queue and wait for turn for it to go through. So you see that it is part of the limitation of this star network. The next one is the ring network, also known as the loop network. I say that it is an improvement on the star network topology where the telecommunication nodes are connected in a ring form. It is exclusively used by the LAN, when we say LAN, local area networks that use token passing or slotted ring access control. In our future lecture, we will be looking at this token passing and slotted ring access control. So at this point, I will, ask you to subscribe to the channel so that you'll be getting notifications when we, and do some of these lectures that take care of some of the things we'll be mentioning, as it may not be specifically for this lecture we are talking about. We can take our time to just look at what token passing and slotted ring mean. In the ring network, each additional node involves system disruptions, thereby reducing performance. Because in the ring, if you want to add another node, you have to shut down the whole system to be able to do that. When you do that, you are reducing the performance of your telecommunication network. Throughput is determined by the medium and the capability of the repeater that is installed at each node. When we say throughput, we are looking at the efficiency of the whole system, because if in each node you don't have enough capacity to, take message and send to the other ones after that node, then the capability of the whole telecommunication system will be drastically reduced. A ring network is vulnerable to a single break in any node or link. In this ring network, you see that if there is a break in a connection between one node and the other, it means that all the nodes after where the fault occurred will no longer work, because it is only one link that leaves the node and goes across to all the other ones. At this point, I would like you to, on your own, try to draw the, a pictorial representation of all this network we have been, talking about. The next one is the mesh network, which is also called the distributed network. They are most suited for long distance transmission between nodes that act as message, circuit, or packet switches. Also, we will in future define these terms we are mentioning here. We have seen token passing. Now we are seeing message switches, circuit, or packet switches. We will take our time to define some of these terms so that we become conversant with them, what they really mean in the telecommunications parlance. Mesh network can be regarded as an extension of both the ring and the star we've talked before. Message delay is usually high because of long distance transmissions. And when we have long distance transmissions, the signal involved began to distort and degrade as a result of fading and interferences. Now, the hierarchical network. This hierarchical network is often referred to as tree network and are commonly used for long-haul broadband transmission. When we say long-haul, we are looking at a transmission that are carrying many signals over a long distance. We call it long-haul broadband transmission. So efficiency is high and only limited by the bandwidth of the medium of transmission. Of course, maybe we will continue to define the bandwidth, which is, in this case, as a result of the number of channels that are allocated for your transmission. This type finds widespread use in public switch telephone network, the PSTN. If you are making use of public switch telephone network, you see that there are hierarchies of local network, the trunk, and even if you are looking at your, mobile, your GSM, you have some, base stations that just collect information, signals, then transmit to a bigger station, and a bigger substation transmits to, a bigger exchange where routing is done properly. So you say such network are referred to as hierarchical network. The single point of vulnerability in a hierarchical topology is the node equipment, and this is easy to solve by having a duplicate of the node equipment, which we say refer to as hot standby. In some cases, we call it a parallel working channel to make sure that when one channel drops, the other one takes up immediately without even the user knowing that something has happened along the line. Message delay in hierarchical network is reduced when independent channels are operated in the frequency division multiplexing mode. Like I said, some of these terms we will continue to define so that you become abreast of them. We also have the bus network topology. These bus networks are usually used for baseband local area networks and point to multi-point terminal. Throughput is determined by the medium and the access control mechanisms. Efficiency generally decreases as the number of stations increases. New stations can be added without reconfiguring the network. You see, efficiency decreases as the number of stations increases, but then it is very easy to reconfigure your system and add new stations without doing much work. So message delay in the bus network in token passing buses increases with the number of stations and sometimes with traffic control. Now we have a hybrid. We've talked about 5 network topologies. Now there is a hybrid one that made it 6. I say that it is a peculiar network. That is, this hybrid is a peculiar network in that the benefits of all the 5 network topologies explained above can be merged to make a hybrid network. They can come in the form of one, a ring topology wired in a star topology, a modified ring using a central ring of wiring hubs, and it can come as a modified ring in form of a loop. However, the decision to adopt any configuration depends on the combination of the following. One, your operating budget, your pocket, the topography of the environment where you are rolling out your telecommunications, and the anticipated volume of traffic. Each topology has its advantages and disadvantages and may be evaluated in terms of one, the throughput. Like I said, when we talk of throughput, we are talking of the efficiency. Two, the maximum distance that can be covered. Three, maximum allowable number of stations that are allowed. As we go down, we will have more information on this. Then 4, the vulnerability to link or equipment failure. 5, message delay, and finally, the cost. Note, it is also essential to know that the various network configurations aforementioned above do not represent physical connection explicitly. It could be any of the available mediums. It could be in form of coaxial cable, microstripe, copper wire, shielded or unshielded, optical fiber, radio link, microwave, and satellite communication, and so on and so forth. Now, let us look at these telecommunications network management. And we say that as telecommunication networks become more complex, there was an increased need to recognize and collect information from the network operations as well as maintain control. A network management facility, which is usually a software, can meet these needs while residing in a workstation and sharing the workstation's resources. Such an integrated management facility, which operates in a shared or integrated environment, depends on techniques that make it adaptable to the peculiarities of the network. It also assists in the development of the facility because it gives you a lot of feedback which helps you to develop more on what you want to do. Now, what are the network management features? As we can see in table 1, the features expected in any management system are listed as control, management, and design. For the control, say that these are the normal operational functions that must be outlined at all times, as well as all matters relating to the network topology and connectivity. And for the management, it includes the support functions that make the network operator's task easier. They can be offline in that they are not required for basic connectivity. Then the design helps in setting up of the initial network and evaluating proposed changes. Typical tools here are tariff files concerned with public network offerings and facilities, traffic analyzers, network and node designs. Now, in a tabular form, let's see the typical features that are expected in any telecommunication network management system. We've said that there are three of them: the control, the management, and the design. Under the control, you have to control your call setup, your call takedown. If it is in a GSM, system, you start talking of call handover to another substation for a mobile user. You also look at the automatic alternate routing, which is known as the AAR. You have to also look at the bumping, the effect of having a connection, in between. Then configuration, the diagnostics, and the alarm reporting. When we talk of alarm reporting, if there is system fault, then the control room should know that there is something wrong. Call it the alarm reporting. Then under the management, we have what we call trouble ticket in case there is a failure somewhere or something is happening somewhere and you know communication is not taking place. Then you should be able to know, because of the vast coverage, the locality where the fault is coming from. Also, under the management, you have the inventory. You have to know the number of people that are connected to your system, what they are doing, and what size of service you need to satisfy them. The vendor files, of course, people connected, you have to have full information about them to know when an unauthorized person is coming in. Also, user records so that you'll be able to charge them. If you don't have their records, you may not be able to, quantify what you are supposed to get from them. Moves and changes, historical statistics that helps you to plan ahead. If you have the statistics of people you are serving, then you will be able to plan ahead to meet their ever increasing demand. Then under the design, you have to, work on the traffic analysis, the network design, the tariff files, and the node designs. So these are the typical features expected of any telecommunication network management system. So now, what are the telecommunications network management types? The management types can come in the form of distributed, centralized, and center-weighted types. The features of these management types are compared in Table 2 under different features. But before we get to Table 2, for the distributed network management, the nodes perform all the functions of the network. Every node has to know everything about the network. And there are things like the routing, the topology, the connectivity, the priorities, the resources, and so on. Now, you see that when every node has to have all this information about the network, definitely it means that in every node, the software looking up all these things must be resident in it, thereby increasing cost. That is why maybe when you want to go and buy antivirus network, virus software, you'll start looking at, say, 5 user, 10 user, 20 user, because in each of these, nodes, the software has to be resident, increases cost. Now, we have the centralized type. So this requires very little activity at the nodes. With centralized management system, one station acts as the supervisory station and controls the entire network, and other stations must receive permission from it in order to transmit. So it has its own advantages, which is few problems in coordinating the activities of the multiple stations, more options in terms of prioritizing access or guaranteeing access to each station, and less logic circuitry in individual stations, thus simplifying their interface to the network. So you see that it has a very good advantage over the distributed one. Then the center-weighted one, say that the role of this center-weighted management architecture is to combine the advantages and best features of both the distributed and the centralized management. So it acts in between, but extracts only the best features of the distributed and the centralized. Therefore, the network assumes aspects of both approaches. The responsibility for controlling the network is then divided between the nodes and the management system. The table 2 shows the network management types and their features. For instance, see the distributed, say the maximum number of nodes in the distributed ranges from 32 to 256, but for the center weighted, it goes from 1,000 to 10,000 nodes. Then for the centralized, it is unlimited. Cost per node is high for distributed, medium for center weighted, and low for centralized. Time for automatic alternate routing to connect is 2 to 15 minutes under distributed, 10 to 20 seconds in the center weighted, but in the centralized is mostly manual. Location of control intelligence for the distributed is equal in every node. In center weighted, it is in some nodes, but mostly in the center one. while in the centralized, it is all centralized. Now, here one can say that the centralized, is advantageous, but recall that fault can occur if it is only in one centralized place. And when that fault occurs, the system will all be down. That is why the center weighted is having it in some of the nodes, so that if the center one fell, then another node can take up that responsibility. Control redundancy, of course, it says inherent in the nodes. Backup processors are the nodes, and same thing as centralized. Node complexity. For the distributed ones, the node complexity is high because every node must know everything about the network. In the center one, it is medium because it is not every node. There may be some localized nodes that know more, but in the centralized, it is low. Size of control processors, limited, unlimited, unlimited. The migration to larger node size for the distributed system is very difficult. For the center weighted is smooth, and for the centralized is relatively simple. Then upgrades, so prompt change in every node. When you are upgrading, the programmable read-only memory must be changed in every node. In the center weighted, it will be only on some of the nodes that have the role to play. And in the centralized, you don't have to change anything, you just change the software. So we are stopping here today. So in our next lecture, we will look further on these management models that can be used to, manage further your telecommunication system. We will become more specific and look at specific models, more especially the SNMP, Simple Network Management Protocol, that is used to manage large heterogeneous communication system. But before we go, I want you to look at these self-tests, and I will want you to provide the answers in the comment section. We will try to, allocate some marks to that, to correct answers. Yeah. And if you didn't get the correct answers, I will be able to, put you through in the comment section. So please do well to answer these self-tests, which is also doubling as assignment to, help you understand better and earn some marks. One, why is the knowledge of life cycle concept very important in telecommunication network studies? The life cycle concept. Two, state the descriptions of what are involved in each of the phases in the telecommunication network life cycle given below. In our lecture, we stated 5 of them: planning and requirement analysis, design, deployment, operation and maintenance, decommissioning. And I gave a hint on the decommissioning that it gets to a point where what you are using is no longer satisfying due to advances in technology or demand. Then you have to decommission that service and move ahead. So I will want you to, provide these answers in the comment section. So thank you for listening. Hoping that by next week, Friday, we will continue in the second lecture and second part of this lecture, which is looking at some operations and management models. Thank you.